All right, in previous videos, we've looked at the definition of a critical number, and here are a variety of functions that one can ask to find the critical numbers of. Remember that a critical number of a function f of x, a critical number of a function f of x is a value of x. We'll call it C for critical number, is a value of x such that the derivative at that value C is equal to 0, or the derivative does not exist at that value C. Okay, so what I want to do in this video is to just look at just an example that is purely um, finding a critical number. Okay, this is such an important step that it's worth looking at a little bit more. Okay, what we're seeing in this problem is a function f of x is equal to x plus the sine of x. Okay, and we're seeing this given by the blue graph here. Here is f of x. Okay, we are also seeing in red, we're seeing the graph of the derivative. Okay, so we know that the derivative, let me recolor these appropriately. Sorry about that. So f of x is equal to x plus sine of x. Okay. And we see the graph of the derivative down below, and we know that that derivative is 1 plus the derivative of sine is cosine. Now what we're looking for are places where the derivative does not exist or where the derivative is equal to 0. Right here are the critical numbers of the function f of x, because the derivative of that function is equal to 0 at this point. Okay, so we want to see about solving an equation. Right? So f prime of x is equal to 0 means that we need to solve the equation 1 plus cosine of x is equal to 0. And so cosine of x has to equal -1. And from the unit circle business, the cosine is -1 at this location, which is at an angle pi in radians. So pi is the answer there, right? But cosine of -pi, you can see -pi over here. You can go around the opposite way. -pi is also an answer. Okay. So one answer that I like for this problem is that the critical numbers of this function are pi. And then if you keep going around again one more time, pi plus 2 pi could be an answer. Pi plus 4 pi could be an answer. Right? And then you have -pi plus 2 pi as an answer. -pi plus 4 pi. You could keep, -pi. We need to keep going around the opposite way. Minus 2 pi, -pi minus 4 pi. And you could keep going on in this fashion. Okay? So there is one example of a critical numbers problem and matching it up with the graph. Okay? We can see here, make some sense of this graph, that everything is making sense, that we've also learned that the derivative, okay, when the derivative is positive, as it is in this region here, we can see that the tangent lines are sloping upward, which means that the function is increasing. F is increasing on this interval. But the derivative always seems to be positive or 0, right, in this example. So what we know about is that there's a sine line for this graph, f prime. We could put -pi and pi on this sine line. And the signs that fill in the blanks are all positives, which means that the function is always increasing. And that's what we're seeing with this blue graph here, that the function starts and the function just keeps continuing upwards. It oscillates, it kind of goes, kind of wiggles a little bit, but the function is always increasing. Okay, so ends this video.